Welcome everyone to this video, part 2 of dual stack networking in Kubernetes. Now, in part 1 of this video, we looked at how a dual stack cluster or pods in a dual stack cluster can communicate with external services in both IPv4 and IPv6. And in this video, we will look at how intra-cluster communication takes place in a dual stack Kubernetes cluster. So let's get started. Now, if you've not watched the first part of this video, please go ahead and do so. We will be continuing from where we stopped. So in this cluster, we will do a Calico get workloads endpoints. And what we can see is each of the workloads for which Calico has assigned IP addresses has an IPv4 as well as an IPv6 address. And what we're going to do next is we're going to ping a IPv6 address from one of the pods in the cluster. So I am going to basically initiate this ping from the first multi-tool pod in this cluster. And if you look at the pod, this is its IP address. So let's ping one of the remote peers scheduled on a different node. So let me copy the IPv6 address of a remote pod. And as you can see, the ping is successful. And what this means is the pods in this cluster can communicate with each other using the IPv6 protocol as well. So we were able to confirm that pods have IPv6 addresses. Let's next look at the services configured in this cluster. So I'm going to copy this command here. And what this command is essentially going to output is the services along with both their IPv6 and IPv4 addresses. Now we have three services in this cluster. The Kubernetes service only has an IPv4 address. We have a dual stack service with an IPv6 as well as an IPv4 address, and a multi-tool IPv6 only service which only has an IPv6 address. Now, when you look at the service definitions, as you're configuring your services, you can specify the IP families for that service. And depending on which families you specify, the service will get IP addresses from those respective families. Okay. So if I'm to retrieve the same output, and this time for the IPv6 service, let me change this to multi-tool IPv6 only. We can see that it only has an IPv6 protocol family. Okay. All right. So next, let's look at how DNS resolution works for these services. So I am going to do a dig from one of the multi-tool pods, the first one, and I am going to do a lookup for the dual stack service. And I was able to receive an IP address of 1096.11.34, which is an IPv4 address. And that's because in my dig lookup, I was requesting the A record for that service. And next, I'm going to do a similar lookup, but this time for the COD A record, which is the IPv6 address. And as you can see, the DNS requests were able to receive as responses both the IPv4 as well as the IPv6 address. So in the case of the dual stack service, it has IP addresses for both protocols. Now let's look at how we can connect to a service. So I'm going to exec into the first multi-tool pod in this environment. I'm going to do first a curl to the dual stack service, and I get a response from that service. And the response indicates that, IPv4 as well as IPv6 is enabled for that service. And then I'm going to do a curl using the IPv6 protocol as indicated by the -6 flag there. And as you can see, I received the same response, which means I'm able to connect to that service using either of those protocols. Now, if you want to get a more verbose output, you could suffix this with a -v, and that would give you also the IP address to which the lookup to that service resolved to. Similarly, next, if I do a curl to the IPv6 only service, I'm able to receive a response as well. And if I do a -v, you can look at the IP address that lookup resolved to. Okay. So this basically demonstrates that any pod in the cluster can connect to an IPv6 or an IPv4 service, provided that they are configured for those protocols. All right, so next let's look at the VXLAN overlay network for IPv6. Now, in one of the previous lessons, we looked at the overlay network in IPv4. Given that we're running a cluster in dual stack mode, in each of the nodes, you're going to find a VXLAN interface for IPv4 as well as IPv6. So in the control plane node, for an example, if I do a IP link show for the VXLAN IPv6 interface, you're going to find an interface named VXLAN-v6.calico, which is the overlay interface for IPv6. Now, in the same node, you can also look at the IPv6 routes, and very similar to IPv4, you're going to find routes to the IPAM block affinities pointing towards the remote IPv6 VXLAN interfaces. Okay. All right. So let me go back to the lab guide. Now you could do an IPv6 neighbor show. And what you're going to find is for each of the remote VXLAN interface IPs, you're going to find the MAC address. And if you do a bridge FDB show for each of those MAC addresses, you're going to find the remote IPv6 node. All right. So again, going from the top, in each of the nodes, you're going to find an IPv6 VXLAN interface. And if you look at the IPv6 routing table, depending on how Calico assigned IPv6 blocks to the nodes, you're going to find routes pointing to the block affinities of the remote nodes. And as the next stop, you're going to have the IPv6 address of the remote nodes IPv6 VXLAN tunnel interface. And if you do a neighbor show, you're going to find the MAC address for those tunnel interface IPs. And if you do a bridge FTP show, you're going to find the IPv6 next hop for those respective MAC addresses. And if you want to understand in detail how the overlay network works, there is a separate video we did previously that looks at this in a bit more detail. So feel free to have a look at it. The process is essentially the same for IPv6 as well. All right. So that's how intra-cluster traffic is routed between pods in the cluster. So when a pod sends traffic to a remote pod, that traffic is going to land in the node's host network namespace. And then the node is going to go through this lookup process and then encapsulate the packet and send it to the remote node's IPv6 address. And then it gets decapsulated and then sent to the pod afterwards, right? And this process, we go through this in detail in the overlay network video in the series, all right? Okay, now if you want to look at the configurations in the top of rack switch, you can exec into that switch as well. So I've done so. And if you do a show run interface VLAN 10, this is the IPv4 address, and this is the IPv6 address for that VLAN 10. And that's how, if you remember in the previous video, we were able to connect to the loopback IP addresses configured in this top of rack switch. If I do a show run, I should see the loopback 0 interface as well. So if you want to inspect the configuration in the top of rack switch, you could exec into the switch and run some of the commands here in the lab guide as well. Okay, so that's it for this lab. To summarize, we looked at how to configure dual stack networking for Kubernetes using Calico. We looked at how pods, the hosts, as well as the upstream switch had IPv4 as well as IPv6 addresses. And the idea behind this is that you can run an environment with both protocols and ensure that your pods are able to communicate using both protocols as well. And this is important when you're transitioning or when you're running environments that have both IPv4 and IPv6 workloads. Okay, so that's it for this video. I hope you enjoyed it. Thanks for watching. I'll see you in the next one. Bye for now.